Welcome back. Today we're going to go through a new topic called properties of geometrical figures. And in today's lesson, we'll look into basic reasoning in geometry. These reasonings that we're going to go through in this first lesson are the types of reasoning that we use to conclude how we got, let's say, side AB equal to side CD, right? We have to use these types of reasonings in geometry so that it makes sense to us on how we got there. Okay, so this list of reasonings, there may be some reasonings in geometry which is not included in this list, but we're just going to look at the very common ones and I guess the very, very easy ones. So the first reasoning is parallel lines. We know that parallel lines are two lines that don't meet at a certain point, right? They just keep going straight ahead. It can be either horizontal or vertical. In geometry and possibly like area, parallel lines are denoted by a type of arrow, right? It points to a certain direction that it's going, okay? These parallel lines will have certain conditions or certain things that come out of these parallel lines, which gives us more knowledge and more reasonings. Okay? So the next one is perpendicular lines. Perpendicular lines are basically, as we know, two lines that meet to make a 90 degree. Okay, this is denoted by 90 degree, this little box. Okay, should be easy. Now, just like I said before, parallel lines will have certain conditions, right, that it will come across. And those certain conditions is the type of angles that a parallel line can have. So between parallel lines, there are three different types of angles, which are alternate angles, corresponding, and co-interior. So let's look at alternate angles. Alternate angles are between parallel lines or a pair of parallel lines, and we need to look for a Z, right? Some sort of Z kind of item. What alternate angles means is if I've got this angle here, angle 33, the alternate angle to that angle 33 will be this one right here, right? This will also be 33. It must be between a pair of parallel lines, okay? The next one is corresponding angles. Again, must be between parallel lines. What I need to look for is either an F shape, right? It can be either like a slanted F shape or whatever, right? Corresponding angles are basically if I have this angle 17 here, the corresponding angle to that would be right underneath. Okay, it's like you go angle, you skip, angle, skip. Okay, that's how I would like to remember it. Same thing on the other side. Doesn't matter if the F is upside down, slanted, or upright. If I have angle 22 here, the angle 22 of it being corresponding is that one right there. Okay. Now we've got co-interior. Co-interior is basically means that it must add up to 180. Okay. It must be between two parallel lines, which I have not shown here. Okay. Between two parallel lines, and you must look for a C type of shape. Okay. Co-interior is basically if I have 10 degrees here, the other angle must be 170 as it must add up to 180. Okay, same thing here. 10 degrees, 170 degrees. Right. The next one is very easy to spot, which is vertically opposite angles. We look for a cross. That basically means that this angle right here, this dot, is vertically opposite to this angle. They must be the exact same. This angle must also be vertically opposite. Okay, so for example, if I have an angle 117 degrees, this angle must be 117 degrees. This angle must be, let's just give it a shot, 23. The other angle must be 23. Okay. Next, reasoning that we've got is isosceles triangles, right? Isosceles triangles is basically where two of its sides are equal. But because those two sides are equal, the base angle, right? These two angles right here must be the exact same. All right. If I have 25 degrees here, that means this must be 25 degrees. That's the condition for isosceles triangle. That's what makes it special. Okay. The next one is equivalent triangle, right? We know that a triangle, it has to add up to 180. So therefore, if an equivalent triangle is all sides are equal, therefore, of course, it'll only make sense that these angles must equal the same, and it must equal to 60 degrees. Okay. The next one is the angle of a straight line. The angle of a straight line, we know that it must add up to 180, right? All these little angles must add up to 180. Okay. Next one is angle sum of a triangle. We just looked into that. If I have X, if I have Y, and if I have Z, all these three angles must equal to 180. Okay. Angle sum of polygons. This is something new, something different. To find this angle sum of the polygon, just like the triangle, right? All I need to do is, okay, how many number of sides do I have? Okay. Minus it by 2 times it by 180. Okay. The next one is external angle of a triangle. External angle means this one right here. Okay, this is the external angle. To find the external angle of this triangle, it's basically adding up the two opposite interior angles. So the two opposite angles that's inside the triangle. Okay, that X and Y. Then exterior angles of any polygons, it must equal to 360. Okay. These are your external angles of this triangle, right? These X's, if I add them all together, must equal to 360. Okay. Hopefully that makes sense, and wait for part 2. See ya. Bye.